double checking if the... Are you getting the... okay, everything is up here, thank you. Thanks for the nice introduction, Matti. And I'm really happy to be back in Krakow. I was there for the first edition as well, and I really enjoyed it, so I was really looking forward to coming back. Talking about something really brand new. As you said, I mean, it's something that this was just an idea at the time, and I only started working on this maybe 3 months ago, so it's exciting for sure. And just a couple of words on me before starting. First of all, I'm really sad about this picture because, as you can see, I had beautiful long hair and I made a terrible mistake this summer, so don't look at me. And then, I got my PhD at the University of Naples. I'm one of the co-founders of a small company called Miniero, and some of you may know me as the author of Janus. There are a few links about me if you're interested in what I do or my hobbies or stuff like this. And just a couple of words on my company as well. So we're a small company that mostly does consulting and stuff like this, revolving around real-time applications, real-time multimedia, a lot of focus on standardization and open source, which is why, for instance, we like WebRTC a lot. And we're based in the south of Italy, which is really not a bad place to live in. These are a couple of pictures taken at our Janus.con event, which is pretty much RTC.ON, but focused mostly on Janus itself. And as you can see, there were also a few familiar faces that you may recognize around the audience. I was really happy that Software Mention participated really in force at the event. But coming to the main topic of the presentation, in general, QUIC has been on my mind for a while because we've all heard about QUIC one way or the other. Some may be already using it, some may think about it. And it was on my mind for quite some time, mostly because there was a lot of discussion about Miniero or QUIC, for instance. And so I started to look into it. And first of all, I mean, I will not go into the detail about how QUIC works and stuff like this, because first of all, I don't know as much. But then, most importantly, there's not enough time for that. So in a nutshell, and don't quote me on that, you can see QUIC as basically a replacement of TLS that goes on UDP, but trying to improve TCP as much as possible. So try to account for all the limitations that TCP has, and improve on those and put them on top of UDP so that you can do it in user space, which makes it easy to update the protocol and iterate on that, but also allow it to use for more real-time applications as well, which is what interests us. Because, of course, QUIC was first born to basically allow you to do HTTP3, so to improve on HTTP itself. But you can actually use it for any kind of application because it's a transport protocol, basically. A transport protocol that is always encrypted, goes on over UDP, but then has features like TCP for congestion control and a lot of interesting stuff happening there. And when you want to learn about QUIC, you soon find out that it's not that easy because QUIC itself, so just the transport protocol, is spread over 4 different RFCs. And then you start reading one and it mentions another. And then you go there and it brings you back to another document. So just reading the RFCs can be a titanic endeavor. And then each of the protocols that you build on top of QUIC are different RFCs as well. And the reading never stops, basically, when you try to look at the specification itself. But I mean, this didn't stop implementers from working on it. There are many very good implementations out there in the wild. And I also found these couple of blog posts by Andy Pierce very useful to learn about QUIC from a very newbie perspective, as I was. So these couple of blog posts go, first of all, they describe how QUIC works in sequence so that you understand the nuances of how QUIC works as a protocol, and then something about HTTP as well. And so I decided, why not try to implement my own version of QUIC, you know? So how hard can that be, of course, no? And so I took my QUIC for Dummies book, basically, and soon found out that it's not really that easy at all. So, I mean, I described in detail, it took about a month to go to a working version, even though it's not really complete yet. But I got to a point where I basically started writing a basic parser, then started creating a basic server, then tried to figure out how I could do the client side, which changes a bit in terms of how you do the setup. And then I got to a point where I could do some basic interop demos with some libraries. For example, IOQuick, Python stack a quick stack in Python was very helpful for me because it has very interesting demos. And this then led me to start working on WebTransport, which is, of course, the first thing that interested me, because that's how you talk QUIC in the browser. And Chad mentioned this briefly in his presentation as well. So when you use WebTransport in the browser, you're actually talking QUIC. which basically allowed me to start playing with this a bit in my fresh new library. So I could take an existing WebTransport demo in the browser and talk to my library, which was acting as a WebTransport server, and send a message and echo it back using different ways, like datagram streams and stuff like this, which was really exciting, which led to the very first attempt to try and bring WebRTC in the picture. So right now I was just exchanging text messages. So what can I do? I can basically try and use data channels on the WebRTC side and then send messages on data channels and then bridge them to WebTransport, so on top of QUIC and vice versa, which basically is what I did as my very first practical WebRTC to QUIC demo. So exchanging messages back and forth using a library in the middle. So basically adding a new custom plugin in Janus that would act as a QUIC bridge in this case. But of course, I mean, this was already very cool and I was over the moon when this worked. But of course, what I really wanted to do was real-time media like audio and video. And so I started looking at what exists today on top of QUIC to do that. And one of those is RTP over QUIC, which is really the first obvious step that you do because we all know about RTP. We work with it every day with WebRTC or SIP or everything else. And so just taking RTP and put it on over QUIC would be a first good start to see if things work. And luckily, there is a specification happening, an effort going within the IETF. And the document, I mean, is quite long. It mostly covers the overlap that exists between RTCP and QUIC, because QUIC already gives you a lot of statistics. It already gives you a sort of bandwidth estimation that will allow for congestion control and so on. So there is a bit of overlap. There is stuff that you can take out. SRTP you will not need because QUIC is always encrypted, stuff like this. But then, of course, you do need also to account for framing, because in this case, you're using QUIC, which is more similar to TCP, especially when you use streams within QUIC, which means that you need to frame packets accordingly, and so on. And so the real meat of the document is that there are different ways to multiplex an RTP packet on top of QUIC. So first of all, you need, you have a concept of a flow ID that allows you to say, to basically specify an RTP session with a unique ID, which allows you to put multiple RTP sessions on top of a QUIC connection. And then you may or may not need to have framing to basically say how long each RTP packet is when you put it on the wire. So it's really simple when you look at it that way. And again, I wrote a detailed blog post if you want to learn more about this later. And this led to basically starting to write a simple demo to do that. So I created, I updated my library so that it would implement this RTP over QUIC protocol. I created a basic client and a basic server application. So in the client, I would receive RTP from an external application and then inject it in RTP over QUIC using different flow IDs for audio and video in this case. And then on the server side, I showed how I could receive these packets. I could demultiplex them looking at the flow ID. And looking at the RTP address, I was sure that I was actually getting the right packets, basically. And so next step was, now that this kind of works, and we know that RTP is used in WebRTC too, let's try to bake that in Janus as well. So I basically updated my Janus QUIC plugin because it was leveraging my library, and so that Janus could act also as an RTP over QUIC client or server. In this specific case, this Janus instance was acting as an RTP over QUIC server, so that I could, from my custom RTP over QUIC client, send RTP traffic via QUIC to Janus. QUIC would receive the RTP traffic via QUIC, take it out from there, and put it in WebRTC to send it to the peer over there. Of course, updating a few of the RTP headers where needed, and making sure that I knew the mapping between flow identifiers used in QUIC and, for instance, the M line in WebRTC that was associated to audio or video, let's say. And I did the other way around as well, so that I could, for instance, have a WebRTC acting as the source of the media. So WebRTC is sending RTP to Janus. Janus receives RTP and then creates a RTP over QUIC client to send these RTP packets to an RTP over QUIC server. And again, everything worked until I tried to do it back to back. So I have WebRTC at the edges, but RTP over QUIC as the tunnel that connects the two. So in this case, I am using WebRTC to send RTP to Janus. Janus uses RTP over QUIC to send it to another RTP over QUIC endpoint. That endpoint gets RTP and sends it via WebRTC again. So as you can see, very easy, very trivial, but already shows an interesting use case where you have the two technologies working together. And luckily, I finished working on this immediately before the ITF meeting in Vancouver. And at the ITF, there's also this interesting hackathon thing happening where developers can meet and try to work stuff out about the protocols that are being standardized right now. And there I met Mattis Engelbart, who is one of the main authors within Pion, and also the main author of the RTP over QUIC specification. And he has his own RTP over QUIC implementation. So we sat there for a few hours and tried to find out if our two implementations were working together. When they didn't, we fixed things, and then eventually we got to a point where it all was working, which was really an exciting moment for us. But again, this was just the first step, because RTP over QUIC is fun because we know RTP and so on, but RTP may not be the best way to do real-time media on top of QUIC. First of all, because, for instance, with RTP, we always chop video frames in multiple RTP packets because UDP forces us to do that. With QUIC, we don't need to do that. With QUIC, we could send a full video frame on top of QUIC, and the QUIC protocol would take care of splitting this for us. It would make it easier for applications to do. And this is one of the reasons why Media over QUIC was born. So Media over QUIC is a new effort within the ITF to try and create a new low latency media delivery solution for the ingest and distribution of media, but in a much more flexible and configurable way, and especially with the configurable latency, which is an interesting aspect that the protocol will have. And from an architectural perspective, it's not that different from what we may know from WebRTC SFUs, because it has the concept of publishers, it has the concept of subscribers, it also has the role of pub/sub, which is typically what relays would do. So endpoints that can receive media on one end and send it on the other side, basically. So not that hard to understand if you're familiar with SFUs in the first place. But what's important, of course, is that in this case, Media over QUIC can go both on top of raw QUIC or WebTransport, which means that you can start using it within a browser, for instance. And then, of course, since QUIC is encrypted, it's already encrypted as well, but you can also do an end-to-end encryption if you want it. It's independent of media formats, and this is another key point that is very important for the flexibility of the protocol, because you can start experimenting with different media by just leveraging the protocol as it is and no change at all. And the support for relays, caching, and stuff like this makes it interesting for the configurable latency, so that if you want, you can watch something in real time or watch it with a 5 seconds delay or start watching again from the beginning, these sort of things. And from an architectural perspective, this is the easiest diagram that I thought about. So you can have a publisher using the Media over QUIC transport objects to a relay, and this relay then distributing it to interested subscribers. So subscribers that are interested in that publisher. So again, this is something that you would expect from a WebRTC SFU as well. But of course, it could be even more complicated. This relay could be feeding additional relays, and these relays could cascade back to other things, and so on and so forth. And this is all allowed by the flexibility of the protocol itself, which is a cool property of the protocol, I think. And in this case, of course, I'm just showing a broadcasting scenario where you have a one-to-many, but MOQ could also be used for conferencing or other use cases. So this topology could be even more complex and articulated, and the protocol allows for that, basically. And from what is distributed on the wire, there is an interesting hierarchical description of how MOQ is expected to work, because again, MOQ is independent of media formats, so it doesn't really care if you're sending audio, video, text, or whatever, but it basically starts from some assumptions in order to decide how it works. And the simplest thing that you can send over MOQ is the so-called MOQ object, so a bunch of data that makes sense for the encoding that you're using. Then you can group multiple objects within a same group, and then a Media over QUIC track, so for instance, a video stream that you're watching is just a sequence of groups, basically, so that each group has some objects in it. And if you look at it from the perspective of video encoding, for instance, you can see a MOQ object as the video frame, so the single frame that you're sending. A group of objects is a sequence of frames starting from a keyframe. So the first object in the group will be a keyframe, and then the differences to that keyframe. And then the track is, as you can understand, the sequence of those objects. So you have keyframe followed by all the differences of that. Then another keyframe and the differences to that, and so on and so forth. And this is your usual video, the distribution, as you can imagine. And this maps nicely to other objects as well. So it's flexible enough to cover multiple use cases. It will probably change a bit because it's not easy to do with scalable video coding, for instance, so there will be changes to that, but in principle, this is the current hierarchical distribution of that. And even if the protocol is very young, I mean, it's been around for a couple of years, I think, there are already many implementations available, and they mostly try to interoperate as often as possible, and especially as part of the activities within the Miniero QUIC working group. So, for instance, at the latest ITF meeting, they discussed an interop matrix where they showed how different implementations worked with each other. And of course, my implementation is not there yet because I was working on it at the time, and it was not really yet ready, but I did mention that I was working on it. So hopefully soon I will have interop reports for that too. But an interesting thing that happened at that meeting was that Meta, and specifically Hordi there, basically did the very first larger scale mock demo, because basically he streamed the whole mock session via mock, which was an interesting thing. So he basically captured the current session within the browser using an implementation that I'll mention later. So within the browser, we would capture the session and stream it via mock to their own relay. And then there was a web page that he shared where you could watch the mock session via mock using WebTransport and web codecs and stuff like this, which was an really interesting demo, in my opinion, and which convinced me that this was the way forward, so starting to experiment with that. And I had already started experimenting with the library itself, so extending my library to support mock as well. I got to a point where I had a basic publisher, a basic subscriber, a relay not yet because that's a bit more complex, but hopefully I'll do that soon. And of course, integrations in Janus, as I'll show soon. And I did a few different interop tests with two libraries in particular. One is mock.rs by Luke Curley, which is an implementation of mock in Rust. And the other is the meta implementations that I'll talk about in a few minutes. And that allowed me to start doing some interop tests. So in this case, for instance, this is my simple subscriber subscribing to the publisher of mock.rs, which streams a video file using an MP4 container that I could then watch after I downloaded it. Then I experimented a bit with text as a content that is distributed via mock, which was an interesting way to test whether or not my implementation was working nicely without having to work with audio and video specifically. But of course, I was more interested in getting that meta implementation working, because I explained how Jordi made that interesting demo that sounded very similar to what we do with WebRTC every day. So you capture a session with WebRTC, you distribute it, and you have WebRTC users watching it. In this case, it was media over QUIC used as a protocol. But in principle, it did sound like something that I could translate to and from in order to do something. And so these are Meta's demos as they are normally. So they have a relay that is called Moxygen, and then they have a web browser implementation of mock to do publisher and subscriber in that repo that's called mock encoder player. And so on one side, I think, yeah, the left side was the encoder, and the right side was the subscriber. And so in this case, this is just a demo that shows how you can use mock end-to-end using their relay in the middle. And of course, I wanted to put myself in the middle there somewhere so that I could do something like this. So have their mock publisher send stuff to their relay, but then have my own implementation subscribe via mock to those objects, modify them somehow so that I could stream audio and video via WebRTC, and then do the same thing on the other way around. So have a WebRTC user publishing audio and video, send that to Janus, then Janus would do something and become a mock publisher that could send it to Meta's relay Moxygen over there, so that their implementation of a mock subscriber could get the media via media over QUIC instead, which is basically what I ended up doing, and I really finished doing like 10 days ago, so just in time for this presentation. So basically, this is a demo that shows the first part. So on the right, you see that that's Meta's implementation capturing video and audio via mock and sending it to their relay. And on the right side, you can see a WebRTC user getting the same audio and video there, which was nice. And in this case, in that other slide, you see the other way around instead. So WebRTC user sending audio and video, and then a mock endpoint subscribing to that. So there are a few things that I had to do. I really cannot go too much in detail about that, but I'll be around for the next couple of days if you want to learn more. And more importantly, I talked about that a lot in that blog post if you want to learn more. But in a nutshell, it kind of worked. It's not perfect, but it shows that it is indeed possible. And so basically what's left to do, and I'd say a lot, mostly because, first of all, my quick stack is incomplete. I explained at the beginning that it is hard and there are stuff that I haven't implemented yet. So I basically skipped some parts just to get to a point where I could start working with RTP over QUIC and Media over QUIC. So it works on my laptop. If the two endpoints are on the internet, it would probably break horribly at the moment. But then, I mean, for sure, I need to keep up to date with Media over QUIC because the working group is very active and the specification changes often. I plan to release all of these as open source soon, but again, I'm waiting for the QUIC stack to be better in general, to improve the library as well, because the way that it performs right now is not really up to, I'm not really happy about it. I need to work on some documentation, which I started, and hopefully that will bring me to a point where people will be able to play with this and provide feedback and possibly even contribute it to that, which is really what I'm looking forward to. And I think I'm more or less on time, so if you have any questions, I'm really open to that. Thank you.
Yes, there are questions. Amazing.
What are the key differences between streaming, let's say, video over WebRTC and MOQ?
Yeah, one of the key differences is related, and I'm probably easier to show with this slide over here, is that, as I mentioned, with MOQ, you can stream whatever you want. And so there will be different kind of container formats that you can use to stream audio and video. For instance, the demo in Rust that I was using MP4 as a container for video, which is one way to do that. But Meta implementation was using LOC, which is basically a so-called low overhead media container or something like this. I don't remember the exact syllable, but it's basically more similar to what RTP is to WebRTC, in the sense that LOC is a small header that contains some information about what this is, the timestamp of this packet, how long the content is, this sort of thing. So it basically contains some metadata. But the key difference is that with MOQ, we can send the full video frame in a single object. So we don't have to chop it up as we do with WebRTC. So one of the things that I had to do with WebRTC, for instance, was I receive a full object with the full video frame on the MOQ side. I have to chop it up in multiple RTP packets if I want to send it via WebRTC. And the same thing, I receive multiple RTP packets via WebRTC. I have to reconstruct a full frame out of that, which means receiving all RTP packets, order them, extract the video frame, and then send that. And in this specific case, but this may be implementation specific, I had to do something else as well. So specifically, the MOQ implementation was using Opus and H.264, and both are codecs that WebRTC supports. But they were using AVCC as a way to encode the bit stream, or the way to serialize the bit stream of H.264. And on the WebRTC side, I mean, it's not strictly speaking Annex B, but it's easier to work with Annex B to how you serialize the H.264 format, because then you put different start codes within the RTP packets and send those. So I had to translate between those two formats as well, which does not mean transcoding the codec, but it means slight differences in terms of how H.264 is serialized, otherwise nothing works. But the main differences are that, yeah, you are free to, it's much more flexible to do things with Media over QUIC in general than it is with WebRTC, because you're more constrained by RTP and a few different things. And then there are, I mean, a few considerations that I haven't investigated yet in terms of retransmissions, because at least from the moment, I think it's easier to do retransmissions with WebRTC because it's immediate. I mean, you know when there is a sequence number gap that this is the packet that you lost, and if you receive a retransmission, you know that this is a retransmission to that specific packet. With QUIC, it doesn't work that way. The retransmissions use a completely different packet number than the packet that was lost originally. And from what I understood, there is no way for you to know that a new packet that you are receiving is actually a replacement of a packet you lost. So I'm not exactly sure what that means in terms of reliability of the protocol, if I'm sure that I received everything and these sort of things. But this is something that is part of the next efforts that I'm planning to work on.
Okay, but in short, is it like, does the lower latency result from no need for packets and using objects, or is it something different?
No, I mean the key aspect difference, yeah, that I failed to mention is that in MOQ you potentially have a configurable latency, which, for instance, and this is easier if I talk about this slide over here, where I talked about objects, groups of objects, where the first object in the group may be a keyframe or something like this. And one thing that I did not specify is that with MOQ you can use different multiplexing methods. So you can say, send me an object in a new stream, or send me a group in a new stream and something like this. But when you subscribe, you can also say, start sending me only the new objects, which is pretty much as WebRTC works. I get into a WebRTC room, I start only receiving the new RTP packets. But when subscribing, you can also say, start sending me from the first object of the group the current object is in, which is useful, for instance, when you're doing video, because in that case, I get in, maybe the last keyframe was 3 seconds ago, they send me 3 seconds worth of frames immediately so that I can start decoding right away because I received the keyframe, all the differences, and then the new stuff. But I could also say, start sending me the first object from the beginning of time because I want to receive everything and I want to buffer and I want to allow people to navigate the video. I mean, this is how it's the flexible in principle. In practice, they are discussing how to implement these because for getting stuff from the past, it may be better to have some sort of a fetch API rather than asking for possibly 1,000 frames to be sent right away as soon as you subscribe, which could create a spike and would work horribly, of course. But in principle, the fact that the protocol has this use case in mind makes it an interesting difference for WebRTC, because if we want to do the same with WebRTC, like seeking or get me the keyframe before I got in and something like this, is harder to do and you need to do some weird manipulations for that to happen. So at the very least, it's an interesting protocol of the protocol, an interesting property of the protocol to look forward to.
Okay, thank you.
Any more questions from anyone?
Maybe related to my presentation a bit, when do you see a production version of the QUIC plugin, the QUIC plugin used in production in one of your customers? How long do you think that's going to take?
You mean the demo that they worked in?
Yeah,
I mean, it could take a while. First of all,
how far off basically do you see that before it actually is used by somebody for real?
Yeah, it mostly depends on when I'll be able to get QUIC to work better, because right now, as I mentioned, it's really just something hacked together to work. I was discussing with Ali, but by the way, make sure to check Ali's presentations tomorrow as well, because he will talk about media over QUIC more specifically as well, which is something that I'm looking forward to. But yeah, I did mention that there are many implementations of media over QUIC transport, but there are also many implementations of QUIC itself. So, I mean, writing my own QUIC stack is what I did mostly because I learn better when I'm implementing something. So that's just how I'm wired. So if I want to learn a new thing, I have to implement it because that's how you figure out potential pitfalls, why something is required and why not. But it may not mean that this is an implementation that we will stick on, because I could, for instance, rely on one of those libraries for the QUIC part and just build the RTP over QUIC and the media over QUIC stuff on top of that, which is something that would be easier to transport the way that it is done right now. So yeah, it really depends on when I'll get to a point where the QUIC stuff is reliable enough, because then it will just be a matter of keeping the media over QUIC protocol aligned. And then, I mean, relying on media over QUIC in production will take some time, mostly because media over QUIC changes often over weeks.
That's more in nature, I guess. My question is like, do you see it settling down?
Yeah, I think it will be faster than WebRTC, probably because there's more activity in the media over QUIC working group right now, but it will take some time. Like, for instance, when we first started using WebRTC, you woke up in the morning after and Chrome reissued an update and nothing worked anymore. So we are in that state right now. So basically, it will be a matter of the specification is stable enough, implementations agree about that, and we are able to use this.
Thanks.
I think that we have time for one more question.
Okay, I have a question regarding use of QUIC for data channel implementation in WebRTC. I wonder how it could be implemented, in particular if QUIC could replace a CTP protocol there. Could you tell more about this?
Yeah, in this case, I mean, SCTP is what we use in WebRTC to implement that sort of functionality. So in this case, QUIC would be your SCTP because SCTP is as a matter of fact, a transport protocol that WebRTC is embedding and using on top of DTLS, basically. So in that case, you could just replace that stack completely and just use QUIC. And in this case, for instance, you can use datagrams or streams to send data back and forth. So you have a bit more flexibility there. I'm not exactly sure whether or not you will have the same flexibility that you have with data channels, because with data channels, you can say, I want ordered or unordered data, I want reliable or not reliable. So you have more control about stuff that you may shoot and never care about whether it gets there or not. With QUIC, you always have ACKs for everything, or almost everything. You pretty much have to retransmit stuff when things don't get there. So this is the main key difference that I expect. But in terms of the media that you exchange back and forth, it's just a transparent replacement of what you send. Because just as with data channels, you can have different channels, different labels, and different sub-protocols on top of that. With WebTransport or something like this, you could have pretty much the same thing, possibly only baked at the application level rather than as part of the protocol. So I see this as an easier replacement than for audio and video. I don't know if this answers your question specifically.
Yes, thank you.
I said it was the last question, but 2 hands went up at the same time, so this will be for real, the last one.
Thanks. My question is about retransmissions over MOQ. I'm wondering if the QUIC layer, it's like the abstraction over which we can forget about retransmission in the MOQ layer, or whether in the working group you're like considering retransmission again.
Yeah, no, in general, Media over QUIC itself doesn't really care about retransmissions because it assumes that it will go on top of QUIC, and QUIC provides all of those functionalities for you. So even, for instance, the congestion control, all the stuff that you typically do with WebRTC in different ways, in this case, you have QUIC doing for you more or less transparently. So the Media over QUIC protocol just assumes that things will work. If you use streams, you know that data will come in order, so you don't have to use a jitter buffer or something like this for media. And so for retransmissions, this is one of the areas where I want to understand this a bit better, because I still don't understand. And if there's any QUIC expert in the room, please feel free to talk to me later, because I really want to understand this, is how what level of control you have over WebRTC over QUIC retransmissions and how they work specifically. Because in general, it works where you, as a QUIC implementation, you send ACKs about the packets that you received. And so as a sender, you see gaps in there, and so you notice whether or not some packets were not missing. There are some timers to figure out if there's still time for those packets to arrive. But in general, that's the way that you do this, pretty much as you do it with WebRTC and sequence numbers. The problem is that when you retransmit stuff, you don't retransmit that original packet. You create a new one, you put the content, the main content that was in there, but not everything, because if that packet contains some ACKs, you remove those and you put new ACKs in, because otherwise it confuses the statistics and so on. But then that QUIC packet has a completely different packet number. So again, you lost packet 9. Okay, now I'm sending you packet 13 to replace that packet 9 that you never received. As a receiver, I receive packet 13, but I have no idea if this is a new packet or if this is a replacement of the packet 9 that I missed. And so when you look at it from an application perspective and you see a stream and you see some holes in there, you don't know if those packets will ever arrive. You don't know if you have to wait for them, or if, like in WebRTC, you can forget about those and move on. So this is really me showing my ignorance about QUIC in general. So it's an area where I want to understand things a bit better. So probably the only part which is a bit more hard for me to understand at the moment. But in general, I do see MOQ as a very interesting thing to look forward to, especially for somebody who loves WebRTC as I do. So I see them coexisting for quite some time. So I don't see MOQ killing WebRTC and let's all go over MOQ. Yeah, no. I mean, I see them living together for a while, which was the main purpose of my demo. But because they have overlapping use cases, but they have different properties that may make one better than the other in some cases and the other better than the other in some others. So that's what I'm still trying to learn myself.
Okay, I think that's nice that at the MOQ layer we can forget about retransmissions and stuff like that. And if I may, I would like to ask another quick question. Can I?
Quick question. How can I say no if it's quick?
A quick question about QUIC.
Okay. At the MOQ layer, do we have any concept about stream synchronization between streams? Like in the header part, like that at that layer you can just look at the header and synchronize different packets, different streams?
I mean, not at the moment, and Ali may correct me if I'm wrong, at the mock object level, no, because the objects are really can be anything. But what you can, and this really falls down to the streaming containerization that you will use within those objects. So for instance, I mentioned that in Meta's implementation, they are sending, for instance, each video frame is put in a video object, but before that video frame, there is a short header that acts a bit like RTP. So it contains metadata information, it contains the timestamp of that video, how long that video frame is, for instance, the codec that was used, this sort of thing. So imagine the regular metadata that you would expect out of those. And in lock, you may have the timing information that you need, because in that case, it could say, for instance, this frame was captured with this timestamp. You look at audio and you see that a timestamp was used for that audio packet instead. And so that's the kind of synchronization that you can use for lip sync, for instance. It means that you are free to implement your own synchronization within MOQ, because MOQ doesn't really care. It just sends object, and the metadata information that you want to add is up to you, which is possibly an interesting feature with respect to WebRTC, where this is sometimes hard to do if you want to relate an RTP audio and video stream to data that you send over the data channel, where it's hard to say this data channel message needs to be shown exactly on this video frame. And you have, it's hard to basically synchronize those, because you don't have a synchronized way of syncing this information, which you do have in MOQ, because you have control over the objects that you send and on the metadata that you send. And so you can pretty much add whatever you need in there. And this is cool if you're doing a siloed environment. It's cooler if you use something standard so that it's the same for everybody involved, which is why lock is being born, for instance, and these sort of things. But in general, MOQ allows you to do, it's more flexible in general. And I guess I should stop, because before you cut my microphone, I should probably do.
I have no intention to do so. But I have the intention to thank you very much for the insight. And also thank you for your curiosity, because it's all started with curiosity. How the hell can it work? So
Exactly. How hard can it be?
yeah. Thank you very much, Lorenzo.
Thank you.